Hey guys, today we're going to work on a really important topic, logarithms. And logarithms are really useful to solve a lot of real life questions involved in exponential growth and decay and finance questions. So it's a really important skill to have. We're going to start out with some basic equations, and our goal today is to just figure out what x is going to be. Now this is a logarithmic equation, and all you have to remember is the word log means exponent. Keep that in mind the whole time. Now, a logarithmic equation should have a base written right here. If it's not there, assume that it's 10. So what this is saying, the log is 2.3. The exponent is 2.3 with a base of 10 that would give you x as an answer. So really what we want to do is sort this out. This 10 is the base. This 2.3 is the exponent. This x is the answer. So to rewrite this, 10 raised to the 2.3 is what? So in this particular case, pretty straightforward. We just use our calculator. 10 raised to the 2.3 is 199 point, so on and so forth. The directions on this sheet, I believe, say round to the nearest tenth. Hundredths, actually. So this is 199.53. So when you can, rewrite every exponential equation as, a logarithmic equation as an exponential equation. Let's try another one. 7 raised to the x minus 2 is 40. Now this is already written in exponential form. What you can do, and this is a very important thing for the rest of this lesson, whenever the x is in the exponent spot, we want to do a equation solving technique by taking the log of both sides. What that does is, if you have the log of a number, let's say I have the log of 9 to the second, instead of finding the log of 9 to the second, which is 81, this 2 can be moved out in front as multiplication. Then you simply would have to find the log of 9 and multiply it by 2. So in this case, when we have this x minus 2 as the exponent, if we take the log, as long as we do it to both sides, this x minus 2 can move out into the front. And then we can solve. Now when you see log of 7 and log of 40, all this means is the 10 to the sum number is 7. This is just a number, it's a value. So to solve for x, we're going to divide both sides by that log of 7 value. So let me show you. On your calculator, the log button's on the left side. When I type in the log of 40 and hit enter, this 1.6 number is really 10 to this number is 40. So make sure you let that print out, then we'll hit divide by the log of 7. So the right side is this 1.8 number. Don't round. 1.8957 blah 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 blah. And then to finish this off, we simply want to add 2 to both sides. So x is 3.8957, and again it says round to the nearest hundredths. So x is about 3.90. Alright, let's try a couple more. Now this next one, we have a base of e. We still have an exponent that's missing, so we want to solve first by undoing this multiplication by division. e to the negative 3x is 20. And now we have our exponent that's missing, so we want to take the log of both sides. But whenever e is in the base, you want to take what's called the natural log of both sides. The natural log is a log with a base of e. And e is a fancy number like pi. It's like 2.718, blah, 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 blah. But the beauty of this is the natural log of e is 1. So whenever you see a base of e, take the natural log of both sides, because this negative 3x is going to move out front. You're left with the natural log of e, which is going to be a 1. And then the right side, of course, we have the natural log of 20. So the natural log of e, again, is 1. This is negative 3x equals natural log of 20. Divide both sides by negative 3. X is the natural log buttons here on the left side. So we hit natural log of 20. Let that print out. Divided by negative 3. So it's negative 0.9985. So that actually rounds to, oddly enough, negative 1. And then the last one, we have missing exponents on both sides. So let's start by taking the log of both sides. No need to use the natural log because we don't have a base of e. The x minus 2 and the x plus 6 move out in front. Now, we want to, what I would suggest is, because log of 3 and log of 5 are messy numbers, let's get them on the same side. I'm going to divide both sides by the log of 3. X minus 2 equals x plus 6. Now this is a messy number. Log of 5 divided by the log of 3. Log of 5, enter. Divided by the log of 3, enter, is this 1.46 number. So this is 1.4649, blah, 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 blah. Now we just have to solve this for x like we're in an Algebra 1 class. Let's distribute this 1.46 number, 1.4649, blah, 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 x, plus, let's distribute, multiplying it by 6, it's 8.7898, blah, 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 blah. Now, let's get all of our x's on one side. I'm going to subtract x from both sides. So this is 0.4649 x, and I'm going to move all the numbers to the left side. So I'm going to move this 8.78 number. So it's negative 10.78. Now you just have to divide both sides by this 0.4649. It's just kind of nasty to deal with all these decimals, but if you use your calculator, the calculator has all the numbers on there. So let's see where we're at here. Alright, I got this negative 10.78 number here, and we want to divide it by, where's that 0.46 number? No, I don't have it here. Let me subtract 1 from that first. Alright, subtract 1. Alright, now we're in business. Take this number and divide it by this last number. Negative 23.2-ish. So negative 23.21 is our answer. So give it a try. Don't stress too much about this last one. It just has a lot of crazy decimals. Use your calculator a lot. And let me know if you have any questions.